In this video, the behavior of the fault-tolerant technique known as StandBy sparring will be described. This video is organized as follows. I will start with a description of the basics of this fault-tolerant technique, and then I will describe a simple extension to this technique that allows a greater coverage detecting and correcting more faults. When finishing this video, the student should be able to define the basic behavior of the fault-tolerant technique known as StandBy sparring. The StandBy sparring technique is a fault-tolerant technique that basically consists on two modules, M1 and M2 in the slide, that do the same function although not at the same time. That is, one module, for instance M1, is operational, whereas the other one, M2 in this example, is used as a standby or spare. There exist also two error detection mechanisms, one per module, called ED1 and ED2 in the graph. These error detection mechanisms can be internal or external. Their function is to generate an error signal, E1 and E2 in the slide, when they detect an error in the working module. After pointing the apparition of an error, the sparring module will be activated. Also, the activation of one of these error signals will provoke that the switch, called SW in the graph, changes its internal configuration in order to connect the system output to the output of the spare, as well as the faulty unit is marked as erroneous. Thus, it is possible to tolerate one fault just using two modules. As it can be seen, this technique performs fault detection, fault location, and fault recovery, as the system is reconfigured when an error is detected. In any case, fault masking is not carried out. Faults may occur, and after detection, the system is reconfigured in order to return to its original status. The error detection mechanisms can be implemented by error diagnosis programs, error detection codes, etc., and they can be used as a safety mechanism. The switch will activate its error signal, called error in the slide, when no more spare modules are available, and the error signal, E1 or E2 in the slide, from the last working module is activated. That is, error signal will be activated when the last working module fails and no more spares are available. So, error detection is used to determine when a module has become faulty. Error location is used to determine which module is faulty, and fault recovery is carried out by removing the faulty module from operation and being replaced with a spare. When implementing the sparring, it can be online or offline. In the online method, also called hot sparring or hot standby sparring, the spare operates in synchrony with the main module, and it is prepared to take over at any time. In this way, it takes less time to replace the main module, although it consumes more energy as the sparring is maintained connected. The hot sparring is recommendable for systems where the reconfiguration time needs to be minimized. For example, real-time systems that control chemical reactors or similar. On the other hand, the offline method, also known as cold standby or cold standby sparring, consumes less energy because the sparring is unpowered until it is needed to replace a faulty module. This involves momentary disturbance in the service. Thus, recovery needs more time. This type of technique is recommendable for systems where power consumption is extremely important, such as satellites. The standby sparring technique can be extended by using more than one spare, as shown in this slide. In this case, the switch presents a design more complicated, as it must be enlarged in order to accept all outputs from all modules. The behavior of this extension is similar to that explained before. As the working module fails, the switch will reconfigure to select the output of a spare. The switch's error signal will be activated when the last spare fails and no more modules are available. Also, depending on the system to protect, the spares can be online, offline, or a combination of these two methods. For instance, some spares can be connected and the rest can be unpowered. With this extension, the standby sparring technique can tolerate more than one fault. In fact, this technique needs two modules to tolerate one fault, three modules to tolerate two faults, etc. In the example shown in this slide, the system is able to tolerate n-1 faults. To summarize what we have studied, we can say that the standby sparring is a fault-tolerant technique able to tolerate n-1 faults being n the number of modules in the system. To do that, it is necessary also a switch to reconfigure the system and to select the corresponding spare output, and fault-tolerant mechanisms able to detect the faulty module. This technique presents two configurations: an online method where the spare is always connected, and an offline method where the spare is not connected. The first configuration is useful for systems that need a fast recovery, while the second one is needed for systems with a high restriction in the energy consumption. Thank you very much for your attention.